Hello, can you hear me?
Yes, sir.
Sir. Yes,
Okay,
sir, we can hear you.
the audio is clear.
Yes, sir.
Okay, so I think we can start. Let's begin. Bismillah. Before that, I must make sure that the sharing works. Desktop, desktop one. Okay, share. Okay. Can you see the slides?
Yes, sir.
Okay. So just recall few things from the last class because there are two sections going on parallel. I need to make sure what was the last topic we discussed in the last class. I think that was also online. Anybody can help me? Uh, I think we should start the concept of keys. Is it right?
Yes,
Yes,
sir.
sir.
Okay. Okay. So schema and instance, I think we covered it. Did we cover this difference? What
Yes,
is
sir.
the
Schema and instance.
we did we cover it?
Sir, I guess no, sir, we didn't.
Okay. And this one, what about this null values, atomic attribute, these things? Did we cover this one?
Sir, I guess we just only touched the structure of
Okay, okay, I understand. Yes, yes, I think this was the thing.
Sir, yeah.
Okay, 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 no problem. That will not take much time. Okay, let's begin. One important notice for today's class is that today, inshallah, we'll finish a very important concept. That's the keys. So it is very, very important in database designing. So you should be extra careful about this topic. Okay, when we'll start. Okay, before that, there is a relational database structure. There are three things you can see. One is called the structure itself. That's the relation. Okay, that's the relation. First one is the structure. Okay. So we have a relation. We call it relation. Okay. And a relation is normally defined by a number of attributes. Okay. There should be a number of attributes. Here, for example, we have ID, name, department name, and salary. These are the attributes. Okay. And these are called records or tuple or rows, all the same. Okay. Is it okay?
Yes, sir.
Okay. Now, okay, let me check. Okay. Now we have two terms. One called is relation and another one is relation instance. Okay. One is relation, another one is relation instance. The difference is very simple. When we call a relation, that means we call about the structure of the table in simple words. Okay. But when we say it's a relation instance, that means we are actually indicating the content of that relation at a particular time. What was the status of different records at last Friday, 10 o'clock, for example? So we have two things. One is relation, other one is relation schema. Okay. So relation is mostly it is fixed, and relation schema is dynamic. Okay. Why it is dynamic? Anybody can tell me why is it dynamic?
It changes during runtime.
Not exactly runtime. We are talking about database. So the records are added, deleted, updated time to time. Okay. So relation schema is always gives you a connection with a particular timestamp. What was the relation schema content in last year, or last month, or last week, or even last yesterday? That may not be the exactly same what we have right now. So in that case, maybe some records are added, maybe some records are deleted. So the contents are not exactly same. It changes over time. And that we capture with the term relation schema. That's why it's called dynamic. Is it clear? Is it okay, everybody?
Yes, sir.
Okay. So now we have okay. So we have another topic is called domain attribute. Okay. Domain attribute is very important. Okay, let me check it. I have another tool to write. Okay. Let's okay. Can you see the board here?
Yes, sir.
Whiteboard. Okay. So domain attribute. Okay. What is attribute?
The quality or
Field of a table. You can think how we define a relation. A relation is defined by a number of attributes. Okay. Let's give example. A student could be a relation. Okay, students. So how I will define it? I'll define it through ID, name, CGPA, maybe all information. Okay. North hall, south hall, whatever. Okay. Is it clear?
Yes, sir.
So here we have this one is called relation, and these are called attributes. Okay. Now, when we say domain of attribute, that means every attribute had its domain range. So it is two type. Okay, we can think of it. It can be defined in two types. Okay, in two ways. We can enforce in two ways. One way already you know. In your C programming, you do the same thing. In C programming, you need a variable of X. How do you do it? You write, okay, something like this.
Yes.
So what you are doing actually, you are binding this variable to a predefined type. Okay. That means the domain of X is now bound to integer value. Is it clear?
Yes.
So the same thing happens here. We'll see in chapter 3 that in two ways we can enforce it. So this is with a basic definition, with its basic data type. within its basic data type, we define the rough, or you can think of its broader domain. Could be ID, could be only the number, okay, or whole could be. Then what should be the whole basic data type? Example, it should be characters, set of characters or string, okay. In the same way, the CGPA could be a number with fraction part, and ID could be a number without any fraction part, okay. ID should not take any fraction. So these basic data types we can define at the time of creating a table, okay.
Yes, sir.
So this basic data type we define within our embedded create statement. We'll learn afterward, okay. I'm just giving a shortcut in our DDL create statement, okay. Here we can mention all these things, okay. What should be the basic data type? But in database area, you have another types of restrictions that we call high level restriction or high level domain. High level domain, what does it mean? We have some business law, for example. Suppose, let's give an example, hall information. We know that it should be a string, okay. But if I want to create one object for the purpose of IoT hall management, then I should have more restriction, not only any string, but I should mention that it should be either south or north or female, okay. Beyond these three, I will not accept any other string, okay.
Yes, sir.
So this is also a domain specification, okay. We call basic data type. So in one way we call basic data type, and there is another way we can higher level. You can say higher level requirement, okay. This is achieved with additional clause of constraint. We'll see, okay, with constraint clause, okay. Normally constraint, okay. Is it clear, the concept?
Yes, sir.
Okay. For example, a particular day, you can make it a day is a, for example, any string, but I can say, oh no, it's only weekends are allowed here. Okay. So we have a additional layer of restrictions, and that can be enforced in DDL with the additional constraint clause that we will see in chapter 3. So what are the two ways we can enforce or we can ensure the domain of attribute? In two ways. Number one, basic data type definition, just like C programming, and then enhanced or higher level requirement that can be captured using additional constraint clause that we will see in chapter 3. The concept is clear?
Yes, sir.
Okay. So it is just like that. You can have a look on it. The same thing in a formal way. That's allowed value. Domain of attribute means the allowed value. Okay. Now, there's a very special guy who's called, when we call an atomic domain, okay? Atomic domain means it has no subparts, okay? It has no subparts. That means you cannot subdivide it. For example, if your CGPA is an example, the CGPA is a number with decimal precision only, okay? It's 3.75, 3.12, 3.00, whatever. So we cannot say it has a middle part or first part or last part. It has no subparts. It cannot be divided. So this is an atomic domain. Is it clear?
Yes, sir.
Okay. Now we have a special thing we call null. Null is not 0, okay? Or it cannot be compared with like a blank as a statement. Okay. Null is very special because null means yet not known, unknown value. We don't know. Okay. It's not zero, not blank. It means unknown. Why this null is very important? We'll see. If we do sums of arithmetic with null value, the result could be another null value. Okay. That's why we should be very careful about this handling of null values. Let me give an example. If an x is a value, okay, if x is a value, suppose x number, okay. Now, if x is null, for example, okay, suppose x is null. Now, if you add with 100, the expression will be a null value. Okay. Because this guy is already a null value. So whatever you add or subtract with a null value, the resultant will be a null value. That's the problem. So what we have to do, we'll see, we will process this guy in a special way, so that if it is a null value, then we will consider it as it is 0 or something else. Okay. In that case, the summation or addition will give you the correct result. Is it clear?
Yes, sir.
Okay. So then we have, okay, now the order is not important. The way things are, the records are stored in database. Okay. It doesn't matter. This record is at the end. This is at the end. This is the first record. It doesn't matter where it is stored in the database. What is the matter? When you display something, okay, maybe the first boy's result is stored at the last record in the database. It doesn't matter. When we will select it based on some criteria and order by, and then his name will be top, and that is the meaningful thing. Okay. The way it is stored doesn't matter. The way it is shown is a matter. It matters. Is it clear?
Yes, sir.
Okay. Okay. Now, just like the relation and relation schema, you remember it? The similar definition is here, what we call database schema and database instance. Okay. So database schema is a set of structure, okay, at a given time. Okay. While the content of that structure is called the database instance. That means this one is a set of, now it's a set, it's not a single one, set of structure, which is normally fixed. But this guy, database instance, it is not fixed, rather it is changeable, dynamic, just like we had relation schema. Okay. So the summary is, we can summarize it. The schema is the structure, hardly changed, while the instance, okay, or data gets changed over time. That's the basic difference. Okay.
Sir, can
Now-
you give an example?
Yes, why not? Let me write it here. Okay, I want to, just 1 minute. Okay. Why it is not going from here? Okay. Let me just fix it. Okay. Okay. So you can think of it. Suppose database schema, we have database schema is we are trying to automate a system of results. Okay. So we have like a number of things like students, Okay. And we have results. Okay. Then we have courses. Okay. These three are relations. Okay. We have relation 1, relation 2, and relation 3. All together, they form our database. Now, what is the content of this at particular time? That makes a database schema. Okay. What is the content of this at a particular time? Okay. So when we look for the content at a particular time, we call database instance. Okay. But when we look for the structure, then we look for the database schema. Is it clear?
Yes, sir.
The same definition. So database instance is changeable. It changes over time, while the database schema rarely changes. Sometimes it changes, but it's very rare, because that describes the overall structure of different relations and their relationship. Clear?
Yes, sir.
Okay. It is also sometimes called snapshot. In Oracle technology, they are termed as a snapshot. Now, today's lesson, basically, it is very, very important. Be very careful about this. If you have any issue, raise your hand. Now, one of the core purpose of relational database is there must be some sound way of distinctly identifying every record or tuple in a given relation or table. Why so? Because if you have a record ID and name, suppose, and you have, okay, sorry, A, B, C, D, A, B, A, C, something like this. These are the values. Okay. If you have something like this, it is of no use. You know why? Because this A and B record is exactly same as A and B. But physically, you are storing two same thing. So there is a consistency problem. Which one is the correct record? Are they same record or the different record? If they are different, how you identify the different record? If they are different record, then it is impossible that you can identify them, because they are exactly with the same value, or all attributes are same. So it is not allowed in relational database. We will not store values like this. Okay.
Yes, sir.
Okay. Now, how do we do it? How you ensure it? There is some process. It's called key. Okay. We use the concept of key to uniquely identify every record of a given table. Okay. Now we have few things here. We have theoretically, we have three things. Okay. We have a super key. We'll define what that is. We have a theoretically, it looks like that. Okay. This is super key. It's a big set. And then among them, there is a subset. This is called candidate key. Okay. And from the candidate key, we pick one particular key, which is called primary key. The relationship is clear?
Yes, sir.
Okay. By the way, the super key, candidate key, these two things are just concepts. Okay. You have nothing to do in your implementation. It's a conceptual development. Only the things that is possible to implement in your database is the primary key. Okay, you will see the primary key constant. There is no super key constant. There is no candidate key constant. Okay, these are the theoretical treatment. Okay, apart from primary key, we have another key that's called foreign key. Okay, this is the reality. This is a real stuff. This is not theory thing only. It has a practical implication. We can declare something as a foreign key. So it is based on the concept of primary key as well. We'll see what does it mean. And the notation that we'll be using, R for relation, K for key, and particular instance is R of K. Okay, R of R or whatever, okay, at a particular time. So now let's see a few things here. Okay, that's better. So a super key is a set of one or more attributes. Okay. A super key is a set of one or more attributes taken collectively allows us to identify uniquely a tuple in the relation. Tuple means record. Okay. This is nothing but a record. Tuple and record are the same thing. Okay. Then we have, suppose K is a subset of R, and the basic definition of super key is here. K is a super key of R if values of K are sufficient to identify unique tuple of each possible relation of R. That means if I can use the K to uniquely identify each and every record independently, then K is a super key. Okay. Then, if we simplify the above thing, this is a simple language. Okay, the same thing but with a different language. So what it says, no two distinct tuples have the same values on all attributes of K. Some portion there should be some difference if K is a super key. Okay. The same thing we can describe in a symbolic format. It says that if these two are different records, T1 and T2 are not same, then their key portion should be also different. So based on this, you understand that it is possible to have more than one super key in a given relation. Let me give one example. Why it is not working? Okay, let me. Oh, just 1 minute. What is this? Just 1 minute. We have to delete, clear drawing, and this. Okay. So let's give one simple example. Suppose you have a name, you have a date of birth, DOB is date of birth, you have a CG, PA, you have an address. Okay. Now, if name is A, B, and C, 189, 92, 3186, 3.5, 3.5, 3.9, address is X, Y, and Z. Just can you hold 1 minute? I have somebody is knocking in my door. Just 1 minute,
Yes,
okay?
sir.
I have to see who's that guy. Hello, okay? Okay, so Can you hear me?
Yes, sir.
Okay. So let's look at this example. Okay. The example is clear. We have 4 attributes. Okay. And we have 3 records. Okay. Now we are saying that let's consider K1 is name, one attribute. Is it true? Can name be alone sufficient to identify every record?
No, sir.
Why not?
Sir. Yes, sir.
Yes.
People may have same names, sir.
No. We assume that this is the content of database. Okay, that's the reality, but that's for concept development. It is important. Only consider what is here in the table. Okay, right now. So name is alone possible to. So it's a super key. Now, if say K2 is CGPA, is it okay?
No, sir.
Why
No,
not?
sir.
People can have the same GPA.
No. Look at the table. Why you are giving the same argument?
The 2 records have the same CGPA here.
Like which one?
The first 2, sir.
Yes, that's the answer. Okay, don't say 2 may have. What may have, that's a future thing. Okay, so this is not SK. Okay, and in the same way, we can think of others like K3 could be a name and address together. I think this is okay. Okay.
Yes, sir.
Yes, sir.
Okay. So this is the concept of super key. Okay. Now let's see what is here. What is that? Okay. We have so we already we have seen that it is possible to have a number of super keys. Okay. Now there's an important property. You see, that's very interesting. If K is a super key, then any superset of K must be a super key. Do you understand why? If K is a super key, suppose K is already super key. Any
Yes,
superset
sir.
of any superset of K, what does it mean? It means you are adding something to the existing K. That's the supersetting. Is it clear?
Yes, sir.
So K is yes, of course. I'm waiting for this example actually. Try to remember it. If K is a super key, if you make any superset of K, that must be super key. You don't need to check it. Let's see this example. Okay, this example. Okay, so here we can see this is already a super key K1. Okay.
Yes.
Now I want to make a superset of K. Okay. I'm using a different color. Okay, for superset of K. So how we can make it? You can add any attribute. So maybe let's make it K4. K4 is K1 union anything, any attribute. Let's make it CGPA. Okay. As a result, it becomes K1 is name and CGPA. Okay. Now look at this K4 and K1. K4 is the superset, K1 is a subset. Conversely, K4, K1, given K1, K4 is a superset. Clear?
Yes, sir.
Yes, sir.
So do you need to prove it that this is, it must be a super key? We don't. Why? This guy is already tested. It is alone is able to identify every record uniquely. So whatever you add here, even the same value, that will be just the additional stuff. That will be different. Now let's apply this one, name and CGPA all together. So A with a CGPA of 3.5. Okay, so we have A 3.5. Okay, this is one record. Then we have B 3.5. Are the same?
No, sir.
No, because it's B. So the other part is B. And we have C 3.9. So because why it will always work? Because this guy, the first part, is already proved that it is alone able to identify every record uniquely. So whatever you add here, that will not create any problem. That's the property we are describing, and this is called a priori property. Okay, there's a famous algorithm on it. Okay, so let's go back to this slide. What it says: if K is a superset, then any superset of K, K is a super key, then any superset of K must be a super key. We don't need to check it. Is it clear?
Yes, sir.
Okay, now, yes. Okay, now, next is the opposite thing. Let's read out the concept of candidate key. Our interest is not all possible super key. It's a huge set. Normally, it will be a huge set. 1 elements, 2 elements, 3 elements, 4 elements, different combinations, all combinations, or there will be a lot of things. Okay, but we are not interested for every element of that superset. We are interested only with a property, and that property is called in super keys for which no proper subset is a super key. A super key, we are interested for a super key where we'll find that there is no subpart of that existing super key that itself is a super key. What does it mean? If there is something like that, that means your first super key is not the ultimate super key. You have a smaller range super key, minimal range super key. So in other language, we say that this minimal length super key we are interested in, and that is called candidate keys. Okay. Let's give one example. Suppose name and address. Okay, I'm not giving that example. Okay, suppose just we have K. K1 is A1, A2, and A5. Now, if we find that this is a super key, okay. In order to make sure this is also a candidate key, what we need to check? We need to check no other subset of this one is a super key. That means if we get A2 and A5, for example, as another key, and we check that this is also a super key, okay, it ensures that this K1 is not the minimum length. We have a smaller guy who is able to identify every record clearly. So we will come here. And if we get, okay, after this we get the, okay, A5 itself is a super key. It is able to identify every record clearly. Then even we will not consider this one. We will consider this one as a candidate key. Okay. Is it clear about what is the candidate key?
Yes, sir.
Okay, we'll give one simple example. Okay, so essentially we are waiting for the minimum length super key. Okay, and among these candidate keys, so it is possible that we have multiple candidate keys, and you have a multiple candidate keys. Out of them, the database designer or the software engineer, the designer, he will pick one as the suitable key, and that key is called the primary. Is it clear?
Yes,
Is
sir.
it clear? Is it clear, everybody?
Sir, example?
I will give you example. Up to now, is it clear?
Yes, sir.
Okay. Now, this is example, okay? So we have we have a relation, okay, results. We have how many attributes are here?
4.
4 attributes, okay? These are the attributes, okay? So let's make some assumption, some tests. K1, so we have a number of Ks, okay? To find out the first step is to find out the super key. Okay, let's see, K1 is name only, okay? Now, can anybody tell me whether this K1 is a super key or not?
Nope.
No,
Why?
sir.
Why?
First
Key
and
mapping
third.
protocol.
Because there are 2 Kims and 2 Johns. I don't know who is who. Very simple, okay? Is it clear?
Yes, sir.
Okay. In the same way, I'm going very slow this area because this is the fundamental concept of database. So if you don't get it, just stop me and ask. Okay. What about the K3?
No,
Is it a
sir.
super? Because
The first two CGPA are same.
they are the same. Okay. So we understand why they are not super key. Now let's see combination, name and program as K4, name and program. So this is the name and this is the program. So they together is able to identify?
No, sir.
No, because of who?
Name.
Which name?
So
There are
John
two Johns on triple E.
Yes,
John, sir,
yes,
John.
yes. We have issues with this one only. Okay. The other 2 were okay. Okay. So they are not allowing us to uniquely identify. John and Tripoli, there exist multiples. Okay. So that's
Sir,
not.
I have a question.
Yes, please.
How name cannot be a super K? Because I think if we like compares like name and CP and anything like it can be super K because I don't know like something like that. If
Can you repeat your question?
sir, if we like if the subset like name and CP can be super K or no,
Mm-hmm.
and like name if you compare name with all of them, I think name can be a super K because name with program is super K, name job as well is super K, name and CP
Yes.
as well is super
Yes,
K.
yes, yes. So what is the problem?
We say it is name here is not super K.
Yes, name is not super key. Okay, we just
Mhm.
wait. The next things are coming. What you are thinking? Okay, name is not super key. Can you explain why
Okay.
name is not super key alone? Because we have Kim, and if it is a super key, there should not be any other Kim, but we have another Kim. That's why name alone is not a super key. Is it clear?
Uh-huh.
Okay. Now you are coming to
Clear,
the
yes.
K5.
Thank you.
K5 name and DOB together, date of birth. Okay. So if you combine it, so we had like problem with Kim. But if you see, if you combine with his date of birth, we have one Kim with date of birth is 1184 and another Kim whose date of birth is 3679. Now they are different. You understand it? Is it clear?
Yes.
So
Yes.
name and if we combine name and DOB is a super key. Now tell me the next line. Do I need to check it that it should be a super key? Do I need to look at the data set for K6?
No, sir.
No,
Why?
no.
We learned
Because-
one attribute, one property that if K is a super key, then any superset of K will also be a
Super key.
super
Super
key.
key.
You see
Super.
K5 and K6. K6 is essentially a superset of K5 because we have just added one thing here. Okay? The same thing coming with addition of CGPA. So even the same CGPA, all CGPA are same, it will be a super key. Is it clear?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so there are other combinations like K7. I don't have any clue because I have to look into the data now. What is the data? So K7, name and CGPA, because name alone is not. Okay, name alone was not able to identify name and CGPA. If that holds or not, I have to look at the data. And if you look at the data, you will find name and CGPA is yes, it is possible to make it a C because they are same, but they are two different name. Okay, so it's a super key. Is it clear?
Yes.
sir.
The last option should be the all possible combinations, all attributes. Name, program, DOB, CGPA. If that is not the case, then there is a problem in the system. That indicates duplicate record. Okay? Remember it. Is it clear?
Yes, sir.
Okay.
Yes,
So this concept is very, very important. Now let's look into the next thing. Okay. So here we have seen how many super key we have? K5,
3, sir.
K6, and K7. What is the length of K5? 2. Length means number of attribute. What is the length of K6
3,
and K7?
2.
2. We told that we are looking for super keys with minimal length. Okay. So out of these, all are super key. Okay. This is our SK group. From here, we will filter only the minimum length. So what is coming here? K5 and K7. That is our candidate key. Okay.
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 Yes, sir.
And among these, I finally choose K5. Okay. Why? That's a different thing. Okay. I'm just making you understand the concept. If I choose K5, will be the working key in my relation in actual implementation, then this guy is called primary key. Is it clear, the transition?
Yes, sir.
Okay. Yes, you can, of course. Why not? That depends on your logic. Okay. Which one will be better, the future prediction and all these things. Okay. This is just a concept. We will find rarely we make this combination. We normally use a single attribute, just like your ID. Okay. That makes life easy to referencing. Okay. Now the concept is clear?
Yes, sir.
Yes, please. Any question?
No, sir.
Okay. Now, so that's the same thing. Now, few things about primary key. So, out of a number of things, we have selected as the primary key. Now, there are some important notes of primary key. Okay, remember it through your life, because you will be working as a programmer, trying to develop many applications in your life, and primary key is the essential part. So you must design in a way that holds the essential properties of primary key. So there are three very important things of primary keys. Okay. Number one, the definition. By definition, it has two things. One is and two attributes are there. It must be unique and it cannot be empty. Clear?
Yes,
Yes,
sir.
sir.
Okay. Now we have very important thing about this primary key is called, when you declare something as a primary key, it creates a primary index. Okay. It creates a primary index. What happens when something is indexed? That means indexing means sorted things. When you index something, that means the first one is top, then second, then fourth, fifth, sixth. So they are ordered. So if you have a list of ordered data, then your search will be, what sort of search you will operate here? Binary search.
Binary search.
Binary search. Binary search is very faster comparing sequential search. Okay. So whenever you declare something as a primary key, those key is already creating one indexing in the background of the database that you don't need to do anything. You don't maintain it. Database engine maintains it. Okay. So what is the purpose? The purpose that it is reducing the search time. Okay. Because now things are sorted based on your ID. So I have basically log to n time. Okay. It is very faster. Even for 1 million records are there. It will have only few steps. Okay. So it has a performance effect. The searching will be faster. Don't worry, there is a dedicated chapter on indexing after the midterm or the theory part of the database or the second half. So we'll do a lot about this indexing. Just keep it in mind right now. If you declare something as a primary key, it is automatically creating one index by the database system, and the core effect is that it is reducing the search time. Clear?
Yes, sir.
Okay. Now, the last thing that is very, very important, the format of the ID, okay, the primary key. It should have two things. One is a few things. It should be informative, okay? And at the same time, we have another restriction. It should be based on non-changeable fields over time. I should not create anything that changes over time. As a result, it will be efficient to implement it. Okay. Let's give one example. Your ID. Your ID is 22, I think, 00.
23.
You are 22?
Sir, 23.
23.
Oh, 23. Okay, no problem. Okay. 23 0042 104, for example. Something like this?
4-1, sir.
Oh,
CSE.
yes, 4. Oh, yeah, 4-1. Sorry.
Same
Yes,
thing.
4-1. Okay,
Same thing.
4-1. Anyway,
Okay.
anything, it doesn't matter. Now you see, if you know this is informative. Why? This 23, it tells that year of enrollment. Okay. This 41 says that it is BSc, CSE. This 1 indicates that you are in the section
Section
1. All these information are very helpful. They are very helpful. So it is informative. Is it clear?
Yes, sir.
Now I am giving another example. Suppose I am designing a company ID. Okay, this very classical design example. Everybody gives this example. We have a lot of designations like junior executive, assistant manager, manager, director. Okay, so somebody joining as a junior executive or something, his ID is J, then 0001. Then next guy will be like Z. Next junior assistant should be 2. And one manager, he should be like M0001. Then manager 0002. Then director D0001. It is very informative because it is giving you the current designation of the employee, and as well as if you get something say 0012, even you can understand among the junior executive whether he is a senior guy or not. So it has a lot of information. Okay. Now, what is the problem with this ID formation? Can anybody tell me? What is the problem?
string and number are together.
And that's not a problem in database area. Yeah, that's the main thing. Changeable. This guy now gets a promotion. Okay, he is now as a manager. So the system compels you, forces you to make a new ID 0003 or something like this. This is a disaster in the system. If you have something that the system is forcing you to change the ID, you cannot retain your ID, then that's a disaster system design, because this effect should be propagated in many, many parts of the system, because ID is the way we uniquely identify every employee. Okay, the payroll management, his leave management, his promotion, his daily attendance, everywhere the ID is there. So it is a very substandard design. If you design something like this, that depends on some field which is changeable over time. Here, the main flaw of the design is that we depend on this bit which is changeable over time. The designation changes over time. So it should not be part of your primary key formation. Is it clear?
Yes, sir.
Everybody clear about this one?
Yes,
sir.
Okay.
Yes, sir.
Because I'm going to set a lot of question on it. Okay. This is so fundamental that even in the final question, I set some questions on from this elementary concept, and half of the students fail to answer it because they don't think carefully. Okay. So the bottom line is that it has two parts, two aspects. One is it should be informative to the end user, but at the same time, it should be made based on non-changeable fields, that it should not change over time. And there should be an efficient trade-off between the information and the implementation, because it's possible to include a lot of information, but the ID will be very clumsy, very big, very difficult to maintain. Okay. On the other hand, the ID could be only single number, just 10001, and then incremental number. That is very efficient to implement, but it is non-informative. So there should be a trade-off between these two. Is it clear?
Yes, sir.
Okay.
Sir.
Now, we have a very important concept. Okay, let's begin, because I don't think I'll be able to finish it. How much time I have?
10 minutes.
10 minutes. 10 minutes is not possible to finish. Just give this idea. Okay. There are another type of keys that's called foreign key. Okay. The basic of foreign key coming from the problem of bad database design. Okay, we have to understand what is a bad database design. Okay, let's think of a bad database design. If you have a bad database design, then it will cause data redundancy. And if you have a data redundancy, that will cause data inconsistency. That's a side effect. These three things are correlated. If you are a bad designer, it will ensure that there is a data redundancy. And if you have a data redundancy, then it will ensure that at the end of the day, there will be inconsistency among the data. Okay?
Yes, sir.
Okay. Now, let's give the formal definition of the foreign key. Okay? Formally, we say a foreign key is an attribute. It could be one or more attribute. Okay? One attribute or collection of attribute, just like the primary key. Okay? In one table or one relation, R1, that refers to the primary key of R2. Okay? So how many tables or relations are involved here?
2.
2. Okay. So primary key is involved in one within a relation. Foreign key now involves 2 relations. Okay. Although it is possible to have self-referencing, that means the same relation can be used twice using a recursive definition. That is also possible. Okay. So we have definitions like R1, the first one, the collection of attribute, that is a referencing table, and the R2 is called the referenced, where it is the primary key. Where it is the primary key, that's called referenced relation. Okay. But that is not very important. The important thing, whether we understand the concept of foreign key or not. Why we need a foreign key? Why we cannot work without the foreign key? How this data redundancy and inconsistency causes without the concept of the foreign key. Or in other words, how foreign key removes the concept of data redundancy and inconsistency. With an example, we will show you with a simple example next class, inshallah, because I have 5 minutes. I have to take the attendance, and as it's a new topic, I prefer it in the next class, hopefully. So up to now, is it clear?
Yes, sir.
Okay. So how many of you are here present today? Everybody?
49.
Let me check it. I have a,
Yes.
let me find out your names. I have the list here. This is group A, I think. You are
Yes, sir.
oh,